Okay, the last question of this packet is dealing with best fit lines. Now we dealt with this on the last one, and I just wanted to go over a little bit more. We use linear regression to find the answer of this when we graphed it. And we used the equation and traveled down that to get the answer. Now if you look right here, so if we look at basically one more thing about this, it's called a correlation coefficient. And that basically tells us how well does that fit the data. If it's not really fitting, we call it a weak correlation. Now, if we were to look at our last problem's example, and we look at the graph, we would say this has a positive correlation. But let's see what the correlation coefficient would be. So what you do is you need to go to second, and you got to turn on diagnostics on. See this setting right here? So catalog, and then you press the letter D, and then you're going to go to diagnostics on. Turn it on. Oop, I went too far. Hang on. Okay, diagnostics on. If you don't press enter, it doesn't turn on. Now it's done. Now if we go right back to where we went before, and we can actually see some more information. I don't need to store this time because I stored it last time. But if I now look, I have some R values to look at. Would we say that this is a close to 1 R value, or correlation coefficient, 0.94? Yes, that's pretty much the number 1. So this is very close. This is a strong correlation. Now if you look at their example, you can see that they have all the points in L1 and L2, and then they turn it on, and you could see right here, if I zoom in, you can see that the correlation coefficient is 0.889, which is pretty much 0.9. Now is that pretty close to 1? I would say so. So we would say this is a strong correlation coefficient. And it would also be a positive correlation too, because it was a positive number.